I'm going to talk about this project that when we submitted the project, I didn't really have an acronym, and then the DAFNI team forced me to come up with an acronym. So the acronym for this project is called NIRD. It means National Infrastructure Resilience Demonstrator. So essentially what we are trying to do is we are going to build a demonstrator for national infrastructure resilience. And what I mean by that, I'll explain through the presentation. First of all, the motivation for our work. In 2021, this report came out from the National Infrastructure Commission, and I think Brian showed it in one of his slides. We actually did a background study for them as well in this report, and one of the recommendations was that there needs to be a capability of stress testing in interdependent and infrastructure networks of different sectors in a systemic way. But the problem is that in order to do that, everybody wants to do systems thinking, everybody wants to do system analysis, but actually to do it quantitatively is a challenge, because we have been discussing this throughout this conference, because there's a lot of data challenges, there's a lot of kind of this whole, how do you also bring different kind of metrics across sectors together, and how do you actually understand systemic failures? And this data and modeling capability, because it's not there, there's also a lack of consistent kind of risk metrics across sectors. And so any sort of like comparison between sectors is difficult. So the kind of motivation of our project, which started last year and is going to go on until April next year, is to build this capability, which will be used essentially to, it has three objectives. One is to stress test infrastructure networks and model these systemic failures and cascades of these failures, and then explore resilience options. In this presentation, I'm going to focus on points 1 and 2 in particular. And essentially what we're trying to do is build, first of all, data sets and a database of national infrastructures for the UK, and then also build this capability and software tools. By software tools, I simply mean like Python codes and modules. And the idea would be that this is all going to sit on the DAFNI platform. And in this presentation, very specifically, I'll kind of concentrate on one bit that we have now finished, which is on the road networks. And I'm sorry, it doesn't have much of interdependency at this point of the project discussion, but we are actually moving towards that very, very quickly. But just to kind of give you a sense of what do we mean by understanding systemic failures. So one of the things we have done is we have built a model for the road network failure assessment at the Great Britain scale. And what this model is, if you look from left to right over here, we've built a very kind of local building to building origin destination routing kind of algorithm for using the road network. And what we're doing is we are then kind of throwing some flood events on top of it, stress testing essentially. And the way we've done is we are doing it in a very generic way so that it can be done in any part of the country. And then we are creating all these impact assessment metrics, which we call as more like systemic metrics, understanding journey disruptions, understanding rerouting losses, and so on and so forth. So to give you a kind of example of this, so one of the things, for example, we've done is what you see the left on the map on the left is the simulation of journeys all across the whole kind of Great Britain for 2021 at the output area level. So this is a very local scale. Output area is as local as you can get with data. And this is kind of simulation of some 11 million journeys for work. So essentially, if you live in Oxford and you want to travel to London, so it's kind of simulation of that journey to work on the road network. And one of the things that we have done is we have kind of built this whole simulation model. So it tells you like travel patterns all across the UK. And the map on the right, with a bit of lighter shades, is the comparison with the average annual daily flow traffic statistics. The problem with traffic statistics is they tell you how many vehicles are on a piece of road or a stretch of road. They don't really tell you where are they coming from and where they are going. So that's one of the reasons why we have built a simulation model to understand journey patterns, because that's what we want to capture. And we have validated, the aim for us is to first, to kind of get a sense of like whether we are getting the spatial patterns right, which in our case we are. And then also we are kind of doing some validating between the two. Although there's a bit of, we have to have a sense of these two models, there's a gaps in validating these two types of data sets, because journey to work might not exactly be same as traffic flows which might capture other type of journeys as well. So we need to be cautious about that as well. But our models are actually doing pretty well in capturing that. So this is this is traffic flows of only cars, and as it says over here. And then quickly, in the interest of time, so what we are doing is we've got some flood events, and one of the questions that has come from us from a lot of stakeholders who are very interested in is simulation of some sort of counterfactual of past historical flood events. So we have some data. We're working with this company called JBA, who probably many people might know in this room. They do some of the best in-class flood maps for the UK, flood models for the UK. So they have kind of provided us, and we're working with them. They provided us these 2007 summer flood maps for the UK. So one of the things we are doing is essentially each of these flood maps gives you very detailed flood outlines and flood depths and all of these things. And it gives you different types of floods, not only river floods, surface water floods, and even kind of coastal floods and so on and so forth. So we essentially use this and superimpose this on our network. And one of the statistics we get very quickly is how many kilometers of different roads are flooded in terms of, so we have 3 flood events. The evolution of the 2007 floods, if any of you, most of you might be aware of this, there was a floods all the way from May to June to July, and so we have like different floods for different months. And it tells us, first of all, how many roads and which roads in the UK's road network were flooded. And this aligns with what was reported as well. For example, the big highways, the M1s, the M5s, and so on and so forth, were most flooded. So we can have some statistics just to report that our model agrees with what was reported as well. And what we are trying to look over here is in these maps in terms of the rerouting and reconfiguration of and effective journeys across the network. So what you see over here, there are some lines which are shown in red, which shows roads which were having an increase in traffic, which were like people were rerouting more towards those, whereas some roads were essentially, those are the ones which were flooded and were losing most of their journeys. So this kind of gives a sense of how kind of essentially the flood impacted disruptions across these networks. And what you can also kind of have another picture is in terms of these kind of hotspots maps of concentrations of areas on the road network where there were journey isolations. Essentially, people in these concentrations could not actually go anywhere using the road network because their connectivity was just broken. And this aligns with, because if you look at some of the news reports that of that time, they were kind of, actually Birmingham is reported, areas around it are reported as a hotspot. There was flooding and there was kind of roads where journeys were not concentrated, not happening. And as you see, there was a lot, of course, in the summer floods, there was a lot of increase of flooding impacts from May all the way to June, and then July was a very severe month. And what we're trying to do in terms of the impact assessment is translate this also into the increased in rerouting costs as one of the metrics, as systemic metrics, as we say. And we have broken this into also into the components that contribute to the cost. So we have a cost, our journeys are costed based on value of time, toll costs, and vehicle operating costs. And we see like which one of these is affected the most because of these disruption scenarios. In our model, at present, we have like, it's value of time which is most affected. So we are going to compare, we have compared some of this with reported statistics. Some of our numbers are high, but then in all of the reported statistics, actually, what you see, they always say there's a lot of uncertainty in these calculations. And so we are kind of actually many times within the range of what was reported. And then we are also looking at how many people were affected, how many journeys were affected. So all of this kind of builds towards this understanding of systemic risk metrics for the road network. And all of this that we are developing, it is all codified and kind of, we have this open GitHub that is accessible. It's already open, and then we are also uploading our data on the DAFNI platform. So in conclusion, the value of our work is that we are developing this national scale capability. So what we showed is a whole national scale network, and we can stress test it with, I showed 3 different flood events in different parts of the country. So we could do it for any other flood in any other part of the country. And then this has led to also creation of a workflow and do the systemic failure analysis. And what we want to further translate this is also into this more economic impacts in terms of vulnerability analysis and these direct damage calculations, which many people here might be familiar with, and also take this kind of similar metrics and thinking to other sectors. And in that aspects, we are kind of also now developing, because this project is about multiple infrastructures and interdependencies. So for example, a work in progress is we are doing a process-based model for the UK's electricity network. So this is a representation of the national grid and the balance of flow between power generation and power demand across the network. So this is a dynamic kind of network that we have. And then once we have developed this model, similarly what I showed on the road network, we want to then stress test the electricity network as well with hazards. And so the capability and the workflows are all in there. We just want to do it for other networks as well. And then, we want to do it for, we have a model for railways. I couldn't present it over here as well. And then, we will then add, once we've done all this stress testing, there's a lot of interest in this, and then we'll start talking about resilience options and recovery as well. So this is a work still in progress. We still have 6-7 months to the finish of our project. This is all I had for you. Thank you very much for your time and attention.